Alright, so we're going to be talking about the mousetrap car project, and first thing I'll do is show evidence that I built my car, which is right here. So the wheels are made out of Gatorade caps, mousetrap's right here, it shows the force, and the back wheels are made of two CDs that I got from the classroom with wood on the side to support while the string attaches to the axle, which I built obviously because I'm at my house. So the first thing we could talk about is how the mousetrap moves. So as you can see on this first graph, this is the position versus time graph on the top, and this is the velocity versus time graph on the bottom. And the m parentheses slope is the acceleration of the mousetrap car. And on the position versus time graph, when it slopes upwards like that, is when the car is speeding up. That is when it's gaining acceleration. And about right here in the center of the graphs is where the graph is straight and the velocity is constant. But after that point, the velocity goes down and it starts to decelerate or accelerate in the negative direction, or the negative way, yeah. So this is speeding up, this is staying constant velocity, and this is slowing down as the car goes from the force of the mousetrap. The second thing we could talk about is the force stored in the spring or the mousetrap before it goes. So we did this test before making this screencast, testing the spring of the mousetrap to see how much force was in it at certain different angles. And so you can see that at 10 degrees the spring force back, there's 1 Newton of force, and 20, 1.3, 30, 1.5, and so on. It's about the same difference between each degree. It's only different between these two because it changes 20 degrees instead of 10 like the previous. So that is the energy stored in the spring. One of the final things I'll show you is the force diagrams for the car as it's speeding up and slowing down. So just open Paint, so I guess we can draw the force diagrams and show you. So let's see if this is big enough. Yeah, yeah. The first force diagram is going to be where it's speeding up, and the force diagram is that it's going to have equal arrows on the bottom and top. That's the center of the force diagram, and then the arrow on the right will be longer because this is the force that used from the mousetrap. And then the bottom and the top are just gravity. Handwriting is really bad on the computer right now. And finally, the other arrow is about half the size, which is the friction. And it's speeding up in this direction because the force of the mousetrap is greater than the force of the friction. And so I just put S dot U for speeding up. And the second one, it'll be slowing down, which the force diagram is pretty much almost identical to the first one of speeding up, except that the friction arrow and the force arrow are going to be switched because it's slowing down, so the friction has more has more power over the force. And these are all labeled the same. Gravity, this is just the Earth pushing up on the car. And they all come out the same, in the same place. And yeah, the force is about half the size of the friction because the friction is more force than